instrument, proper technique. So this will be the procedure, no, the correct procedure for uh, this kind of instrument. Okay. For total station, we have the proper technique or proper procedure for that. Okay. And, or by adopting a field procedure which will automatically eliminate it. Okay. So if there is a field procedure that will eliminate, let's say for example, if the if the temperature is too hot, then eh, we are very sure, no, if the temperature is too hot, is too high, then our tape is too long. No? Okay, if the tape is too long, if we have this procedure, no, a procedure or process that may eliminate the if the tape is too long, then we can apply that one. We can use that. Okay, because it's part of the systematic error. So in surveying, errors occur due to instrumental factors. So instrumental factors like, for example, the if you did not adjust, no, there is no adjustment in the uh, on the equipment, no. So one of the factors there is a instrumental error. Okay, there is no calibration, no. If the instrument is damaged, no, so we expect that the errors may occur. No? Okay, the natural causes like the temperature will be the natural causes of that, and human limitation of the observer. So we consider this as human error. That's part of systematic error. So we have also this accidental error. So this error are purely accidental in character. There is for example, uh, in the course of the surveying, no, you accidentally move, no, the equipment. So when moving the equipment, uh, then that may cause some error, no? Because the equipment, maybe the equipment is not, di ba? Kung mag-move siya, ang iyahang pag-balance niya, dili na siya balance, no? Dili na siya balance. So, or dili na siya level. So, the tendency is when you do some measurement, if the equipment is not level, then there is a tendency that may occur some error, okay, because of the accident. Okay? Okay? The occurrence of such error and matter of chance as they are likely to be positive or negative. And it may tend in part to compensate or average out according to laws of probability. And may tend in part to compensate or average out according to the laws of probability. You get the we should have to compensate the errors now. Yeah. Maybe you can apply the corrections. Okay? Or get the average of that, or the mean. Okay? Okay, there is no absolute way of determining or eliminating this them, since the error for an observation of a quantity is not it's not likely to be the same as for a second observation. Maybe you committed this kind of error, accidental error, no, on measuring point one and point two. Then in measuring point two to point three, there will be no the same, no? There will be no the same errors that may occur during the observation of a quantity. Okay, we have that. Okay, now for a while now. Okay, so we have that. No? One perfect example for accidental error here is the failure of the tapeman to exert the correct amount of pull, no, on the ends of the tape during measurement. So this is part of accidental error. And also the reading of an angle with a transit, the instrument man cannot read it perfectly or read it perfectly. There will be times when he cannot read it perfectly. There will be times when he cannot read it a value which is too large, and in another attempt he may read a value which would be too small. So that's part of the accidental error. So the next is we have the instrumental error. Okay. So we have an instrumental error here. No? This error is caused by imperfection, no, in the instrument used, either from faults in their construction or from improper adjustment between the different parts prior to their use. No? There is what we call here as manufacturing. No? Uh, there is a fault during manufacturing of the equipment, no? And improper adjustment, no, on the equipment or the different parts prior to their use. So that is caused by because of this, no, manifestation. Then we have an instrumental error. Surveying instrument, just like any other instrument, are never perfect. No? Okay. Proper corrections and field methods are applied to bring the measurement within certain allowable limits of precision. Corrections and the field methods or field techniques that we are going to employ, no? Okay, during the field measurement. Okay, we should have a high value of precision. Okay, to avoid that one, to avoid the error, we should do some. The value of precision is should be high. Okay, with time and continuous usage, the wear and tear, no, of the instrument will likely be a cost for errors. No? The depreciation, the depreciation of the instrument, no, may cause some error. The wear and tear, no, of the instrument. Okay. Example of instrumental errors: measuring with self-tape of incorrect length. Okay, that's instrumental error. Number two, using a leveling rod with painted graduations not perfectly spaced. Okay, and the calibration, there is an error already. Okay. Number three, determining the difference in elevation between 2 points with an instrument whose line of sight is not in adjustment. Okay. So it should be fully adjusted. No? Sighting on a rod which is warped. No? What is the meaning of warp? Huh? What is the meaning of warp, class? Damage, no? There is a damage. Either that is, according to the synonyms here, change, damage, distorted, misrepresented, confused, no? Maybe distorted, no? Distorted siya. Okay. Improper adjustment of the plate bubbles of a transit or level. So we have here 5 examples of instrumental errors. Okay, we have the natural error. So these errors are caused by variations in the phenomena of natural, such as the changes in magnetic declination, di ba? During our previous meeting, I have discussed this magnetic declination. This may cause some errors, no? So 20 years ago, the magnetic declination is this one, no? Okay. So in 2023, we have this kind of magnetic declination. That is the declination between the true north and the magnetic north, for example. The temperature, variations in temperature, humidity, wind, refraction, gravity, no? Katang ang line of sight niya, there is a refraction for that, no? Caused by, let's say, temperature, no? Okay, kanang iyahang imuhang sight nimo, no, mo deflect, no, because of uh, the true shape of the earth, no? There is a refracture. Okay? Gravity and curvature of the earth. So refraction, because maybe sometimes ang temperature mo will cause some refraction. Gravity and curvature of the earth. It is natural error. The surveyor may not be able to totally remove the cause of such error, but he can minimize their effects by making proper correction of the results and using good judgment. So here is the common example, no, for a natural error. So number one, the effect of temperature variation on the length of the steel tape. Okay. Error in the readings of the magnetic needle due to variations in magnetic declination. Number three, deflection of the line of sight due to the effect of the curvatures, earth curvatures, and atmospheric refraction. I stand corrected, not temperature, but atmosphere, in terms of its refraction. Okay? The effect of the Earth's curvature and the atmospheric refractions. It may cause some errors on the line of sight of the equipment. Okay? Number four, error in the measurement of a line with a tape being blown sidewise by a strong wind. Number five, error in the measurement of horizontal distance due to slope or uneven ground. So aside from the natural error, we have also this personal error, no? Or human error. No? So this may cause from the limitation of the senses of sight, touch, and hearing of the human observer, no? Which are likely to be erroneous or inaccurate. Yeah, okay? Some personal errors are constant, which are compensating, while others may be erratic. Erratic kani, it may change, kani gamay pa lang, mukalit o taas, no? That is erratic. Okay? Compensating naman, pwede dayon kuan nimo ma-correct. It can be corrected, no? Say constant. Mao na gud na yang error, no? Okay? Error mao gud ni siya. From starting point going to point number 2, point 1 to point 2, point 3 to point 4, the same errors, no? Okay? Uh, Personal errors are significantly reduced or eliminated as skills are developed in surveying operations through constant practice and experience. Okay. If you have, if you, okay, if you constantly, no, do the survey of this, let's say, this kind of a surveying activity, then maybe mamaster nimo, no, kung saan kuan, and then expected errors, no, for this kind of survey, anticipate na nimo, no, you can immediately adjust it, no, and of course your experience, no, is very important. Your experience. Okay. Errors of this type are also eliminated by employing appropriate checking of the procedures in the taking and recording of the measurement. Taking nga ni kanang uh, kung taking ka na kanang mo you have to about to read the ano the measurement, no, and then record it, no? So that is taking a recording of measurement. Okay. Okay, the procedure of that will be checked, no? Okay, will be checked appropriately so that you can minimize or eliminate this kind of error. Typical of these errors are error in determining a reading on a rod which is out of plumb, no, during sighting. Out of plumb na ni, nahiwi siya, no? Dili siya naka-center sa imong kuan, sa imong marker, no? Out of plumb, or di siya naka 90 degree, no? No? Okay? Kaya ang plumb line should be perpendicular to the line of sight. Perpendicular to the plane. It should be. No? Errors in the measurement of the vertical angle when the crosshairs of the telescope are not positioned correctly on the target. So that's one of the errors here. Making an erroneous estimate of the required pull to be applied on a steel tape during measurement. If the required pull, standard pull is this one, kusog tayo yung pag-pull, so there may be an error. Or steel tape, you make the steel tape too long, no? Because of you have excessively pull, no? Excessively pull the tape. Okay. Okay. Any question with regards to the error here? The types of error or errors in measurement? Any question? Mr. Amores?
Sir, kanang as a professional, sir, what is the most challenging aspect of dealing with measurement errors?
Dealing with the error as a professional. Huh?
Sir, what is the most challenging aspect of dealing with measurement errors?
Because we have different scenario, you know, different errors may come up, different surveying activity, you know. Every surveying activity there is an error for that, error. Okay, so as what I have mentioned earlier, no? Number one, wala na siya approach nga sakto gud ng approach nga nani. But your experience, no? Your experience will tell you that you have to do this and do that, because our experience is our good teacher. No? Okay, experience is our good teacher. It may guide us. No? Pag sunod na sa ginagawa, we can anticipate this kind of error already, no? Based on your experience. Then you you have to adjust it. No? Kung sa man ang type of error na mo come up diha, no? Okay, that is the perfect approach, no? Being as a genetic engineer, no? As a civil engineer, that will be the perfect approach for that. So in your case, kanang mga inexperienced na mga students like you, so what you're going to do is you have to be very careful, no? Okay, you have to be very careful. See to it that you have execute, no? You execute it, and not just di man ta maka-perfect ang pag-execute, but we have to minimize the error, no? na may kuan diri nga unsa niya, you have to you have to be very careful, no, kanang mga imong mga errors, you can remove that one, no, or we can minimize that. Uh, Even your good judgment or even your experience will give us, or if you don't have any experience, kanang mga proper na mga procedure, no, proper procedure, uh, sa pa sa pangakuan, kanang mga we have to execute it carefully, no, so that the errors may not be not not it will may na kumbaga kuan baka nang dili siya mo accumulate or ma-stop dahil na to, no? Okay, and what else, maybe yes, careful work, no? And applying the corrections, no? Okay, that is number one, careful work and applying the corrections. You have to use our standard, no, exact standard. Okay, you have to execute the surveying activity carefully, no, careful with care, and from time to time we have to apply some corrections, no? Okay, that will be the perfect approach that in that one, in that case, no. Okay, kasi kining mga errors moabot ko ni siya, there will come a time na moabot lang ni siya, no, like for example, the temperature alone can give us an error for that, the temperature. When you measure a distance using tape, no, the variation in temperature will give us an error. So kailangan proper procedure, kung experience na ka, kabalo na ka kung unsang pag-approach ana, no? Okay, pag-approach ka na, for example, if the temperature is uh, standard temperature is like this, no, if the temperature, let's say standard temperature is 35 degree Celsius, no, 35 degrees Celsius, there will be no error for that, no? The tape is in standard, no? Greater than 35, it may cause some error because the tape will become too long. So you do some adjustment for that. Yes. Example, you have computed that the the variation between the standard and the actual measurement is there is a 5 centimeter too long, based on the temperature. Because of the temperature, you have to adjust your measurement. You have to adjust it. Okay, nakuha ba ninyo? Nakuha ba?
Yes, sir. Yes, sir. Thank you.
There will be no perfect approach for that. Ang kuan lang, ang bantayan lang nato, if you are an experienced genetic engineer, then mas nindot imo ang kuan kay you have the experience already. Kung inexperienced man ka, careful lang ka pag survey, careful lang ka, gamit og common sense sometimes, no? Tanaw nimo nga ang imong, like for example kato yung facing ninyo, no? Ang uban ninyo ako na kayo ang kuan, diferensya sa iyang kuan, XY and YX, then we have to use our common sense, no? Kabalo na ta nga pwede nimo siya dili adapt tong kuan. Usabon na sa nimo, usabon. No? Kasi nakalimot lang kapag pag-ihap nimo, no? Nakalimot kapag ihap. Okay? Kana bitong nag-ihap ka nga kuan sa uy, unsa man to? Wala man kung naagi og kuan, wala man kung naagi 35. Diretso man ko 37. 35, 36, diretso ko 37. So, you'll be coming up with an error for that. Ako ba ninyo? Ha?
Yes, sir.
Okay? That's why ang in in our kining atong mga literature here, kanang mga literature approach nato diri nagasuggest lang sila, wala gid ko nakakita libro nga this is the perfect approach, no? This is the correct approach that you are going uh, to do, no? If you have this kind of error, this is the perfect approach. That there is no such thing as a perfect approach. Even kanang mga sikat ng mga author sa libro, wala agad sila nagatuan. Nala mga situation nga gibutang nila, nala sila suggestion nga siya. Na gani pa lang statement nga surveying instrument are never perfect. Na? When you say never perfect, na? Manufacturing of instrument alone has an error. There is a certain kumbaga ang iyang magnetic needle dili siya kuwang siya ang iyang kuan. So there is a tendency that there is already an error because of the surveying instrument. Okay. Another question? Another question? Huh? Huh? Joseph? Join mo din. You can unmute your mic if you have a question. If you have any question, you can unmute your mic. Huh? Question?
Good morning, good afternoon, sir. I have a question, sir.
Yes, go ahead.
Can you explain the process of instrument calibration, sir, since important na po na to reduce errors? Can you explain the process of instrument calibration and how it helps reduce instrumental errors, like sa total station? Like that, sir.
Calibration is when you do as a calibration, there is an expert, no, calibration to do the calibration. For example, you have to calibrate when calibrating a measurement of angles, horizontal angles, na siya yung mga standard na buhaton. Na sila standard ang kuan na perfect na siya na gibuhat nila. So yung mga instrument, i-try na siya kung makakuha nga ni the same na kuan na value, then wala problema. There is no problem with your instrument. But that is part of calibration process. Kung naamay sa'yo, na-error yung kuan, they are going to adjust it. They are going to adjust it. Example, kanay mo ang mga pagkuha sa mga asimov, sa standard, no? Na-error pag tanaw niya, na-error mga 1 degree ang error. So you have to, they're going to calibrate it. Okay? Like example, ang tape. No? To calibrate the tape, nasa sa po dito ng 100 meters. No? Or 10 meters. Tanaw niyo mo ang tape kung tama ba siya ng 10 meters ba. No? Standard na siya ang kuha na standard. So kung mula ho siya nga wala may kuan, wala may influence sa imong environment, no? So something is wrong with your tape. You have to change your tape. Di ba? Dili naman makalibrate ang tape. Di ba? Ang steel tape, di naman makalibrate. Di man pwede nga putlan na lang nato ni. Kaya nalapas na siya, no? Kaya di naman pwede. Unlike in equipment, nga pwede siya makalibrate. Ang pananglitan na yung distance measurement of total station. No? Mali na siya, may standard. So there is a sort of calibration process. You will do some calibration process with your total station para makuha niyang exact na value. Okay? Okay?
Okay, sir. Thank you, sir. So, like, double checking, di ba, sir, is like, it's also part of the calibration of double check.
Ang double checking is that is within the surveyor. Nasa surveyor ng double checking. Pwede niya usabon niyang kuan. Pero when you say calibration, naagoy standard ano niya. I mean, kung gusto mo i-check yung horizontal angle to measure, so ipakalibrate mo. Na dito standard nila nga kuan, perfect ko na siya nga horizontal kuan. So, mo try na sila measure, pag measure na nila nga na something is wrong with your instrument, na siya dili siya parehas sa inyong kuan value, then i-calibrate na nila, i-adjust na nila. No? I-adjust na nila. Okay? So maybe every 3 years there is a calibrate. You have to calibrate your equipment every 3 years. Ang uban nga ni every year ipakalibrate nila ilang kuan equipment. There is no shall we say there is no correct kuan kanang correct na time na when to calibrate, no? When to calibrate your equipment. There is no fast rule for that. There is no fast rule in the calibration of the equipment. Okay ba? Kuha na to?
Yes, sir. Thank you, sir.
Another question? Another question? Huh?
Good afternoon, sir. Question.
Hmm.
If ever you're in the field, sir, and the data you gathered has a lot of errors, do you need to repeat your survey again, sir?
Kung a lot of errors already, then you have to repeat. You have to repeat it. Ang ako ang basis ana, if I have more than 2 errors, then I have to repeat the measurement, field measurement. That is a good question. Okay? Because if you continue, no, if you continue, then there is a tendency na ma-accumulate ang imong error, no, from one point to the other. Diba? You have to repeat it again. Kasi naalam mo yung nagkamali, human error ba or something na may accidental error siguro, naitabo. So you have to repeat it. Okay?
Okay, sir. Thank you.
Any other question? Any question? Huh?
Question, sir.
Hmm.
Sa among course, sir, ba kay tudluan ba may sir if kanang mag-calibrate sa mga sa kuan sir mga equipment sir or wala na sir kay for instance sir kanang nami tool sir pero walay kanang kamao mo calibrate sir ba so dili may makagamit sa mga equipment sir.
Dili ta mo calibrate. Kay we are not the expert for that. Dili ta mo calibrate. Only the expert can do the calibration. They are a certified calibrator from the company. Dili ta na pwede. And dili mo tudloan pag-calibrate. Kaya dili na nato ang kuan. Atong purpose here is to come up with the surveying measurement. Wala atong purpose dali. Unsa may pakaibaw nga dili ni siya kuan standard. Eh di man ta kabalo sa kuan. Mo assume na lang ta na walay error nga may tabuan na because of this instrument, no? Or caused by instrumental error. Okay? Pero the rule of thumb there is we have to do some calibration, maintenance man ang calibration, no? Maintenance of your equipment. The other genetic engineer, they do it every 3 years. They have to calibrate their equipment. No? There is their person. There is a company that the one who calibrate, the one who will calibrate the equipment, not the surveyor, but there is a company, an expert company about the calibration. They are certified, no? So, for example, they are certified by the Topcon, no? Topcon, one of the makers of the total station is Topcon. They are certified with Topcon to do some calibration. Okay? Cordio?
Ay sir, thank you sir.
Any other?
Sir,
Festival.
kanang kuan sir ba,
Hmm.
magdepende ba na ang kuan sir sa imo like sa imong shielded light or kuan sa brand sir, ang imong quality sa imong like sa imong pag-survey nim sir, sa imong tools
That is a
ba?
yes, that is a good question. Magdepende ba sa brand? Just like cellphone, no? There is a difference ba if you are using iPhone or if you are using a Samsung, if you are using a Nokia. Really, the purpose is the same. No? Based on the standards, nakapasa na sila tanan. Otherwise, dili na siya makapasa sa kuan ng mga international standard nga gitawag nato. So, depende na sa kuan, naalay uban nga mga gitawag nato nga mga brand nga easy to use. I mean, pag kuan pa lang, pag level pa lang, nindot na siya i-level, no? Humok kayo. So siguro they have their features about that one. No? Ba? In terms of its measurement, the same ko na siya mo come up. The same ko na siya. Okay? And our concern is the measurement, di ba? Measurement mo itong kuan, katong mga basic surveying operations or quantity or measurement. Mao man tong gihabol diri sa kuan. Okay? Any other? Any other? Go Dennis.
Wala ra sir, na-join na akong balik.
When ako, your any question? Okay, before we proceed to another topic, no? Subtopic, then we have 5 minutes, no? Break. Okay. Okay. Okay, we're back. Okay, am I audible?
Yes,
Yes,
sir.
sir.
No? So we come now to MPB. No? We call this as most probable value. Okay. So in MPB, we our basic assumption here, no, for the theory of probability will be used, no. Okay. The theory of probability, that will be our basic assumption for MPB. No? The most probable value of a group, no, of repeated measurement made under, no, similar conditions in the arithmetic mean or the average. Okay, that is one assumption here. Huh? Arithmetic mean or the average. Okay. If there is any group, no, of repeated measurement, then the MPB here will be the most probable value is the arithmetic mean or the average. MPB has been defined as it may refer to a quantity which, based on available data, has more chances of being correct that has any other. No? There is a probability, no, or chances to that the value is correct. No? Okay, that is MPB. No? So if a given quantity is measured more than one time, no? So more than one time, we have several measurements here, resulting in more than one value. Not all the desired values are correct. Maybe the other value is wrong and the other value is correct, and only one correct value that should be considered. Okay, if we have more than one quantity is being measured here. Okay, so we have here the principle of the least square, no, the theory of probability. Okay, MPB is equal to bar x, or equal to, we are going to determine the mean, no, or the average here, no? Summation of x, summation of the series of measurement divided by the number of measurements here. No? Okay. So MPB is equal to bar x, the most probable value of the quantity measured. And the summation of x is the sum of individual measurement. The sum of individual measurements here. Okay. Example of the MPB here. No? A surveying instructor sent out 6 groups of students to measure a distance between 2 points marked on the ground. The students came up with the following 6 different values: 250.25, 250.15, 249.9, 251.04, 250.50, and 251.22. Now, as you can see in the 6 different values, I think they are not equal, no? So there must be an error for that. We don't know which is the correct value here. Okay. So what we are going to do is to apply the formula. Okay. To determine the most probable value, most likely the correct value. Okay. There will be only one correct value for that. With a given value or values, so we can take the summation, no, from x sub 1 up to x plus 6 divided by 6. No? So we have here MPB is equal to bar x is equal to 250.51 meters. This is the MPB of the distance measured. No? AN. Distance measure. Okay, that is our answer. Okay. Another example for to determine the most probable value, we have the angles above a point Q have the following observed values. We have 230 degrees, 15 minutes, 20 seconds. Another value, we have 142 degrees, 37 minutes, 30 seconds. And we have another observed value here. We have 87 degrees, 7 minutes, 40 seconds. So determine the most probable value of each angle. Okay. So letter A, first to determine, we're going to determine the correction to be applied. Okay, this will be the correction to be applied. No? The sum, no? The sum of the measured angle of observed value. Okay, so theta 1, theta sub 1 plus theta sub 2 plus theta sub 3. No? Okay, and the sum is equal to 130 degrees, 15 minutes, 20 seconds plus 142 degrees, 37 minutes, 30 seconds plus 87 degrees, 7 minutes, 40 seconds. The sum is equivalent to 360 degrees, 0 minutes, 30 seconds. Okay, this is the sum of the angle observed about point Q. If you notice that the total angle here, in one revolution here is equivalent to 360 degrees. No? So there will be some discrepancy. No? The standard is 360 degrees minus the observed angle, 360 degree, 0 minutes, 30 seconds. So the discrepancy is negative 30 seconds. No? This is the discrepancy in the observation. So the correction will be this discrepancy divided by n. N is equal to 3. Okay, tuluman ng angle. Okay? Negative 30 degrees divided by 30 or divided by 3 is negative 10 seconds. This is the correction. Okay. Determining the most probable values. No? Theta sub 1 prime is theta sub 1 plus or minus the correction is equal to 130 degrees, 15 minutes, 20 seconds minus 10 minutes. So theta sub 1 prime is equal to 130 degrees, 15 minutes, 10 seconds. So we have the most probable value of theta sub 1. Okay. Theta sub 2 prime is equal to theta sub 2 plus or minus a correction that is equivalent to 142 degrees, 37 minutes, 30 seconds minus 10 minutes, 10 seconds rather. So theta sub 2 prime is equal to 142 degrees, 37 minutes, 20 seconds. This is the most probable value of theta sub 2. Okay. Okay. Theta sub 3 prime is equal to theta sub 3 plus or minus the correction that is equivalent to 87 degree, 7 minutes, 40 seconds minus 10 seconds will be equal to theta sub 3 prime is equal to 7 degree, 7 minutes, 30 seconds. This is the most probable value of theta sub 3. That will be the answer. Theta sub 1 prime, theta sub 2 prime, and theta sub 3 prime. That is the answer of the question in the problem. Determine the most probable values of each angle. But we need to check it. Solution check here. Theta sub 1 prime plus theta sub 2 prime plus theta sub 3 prime is equal to 360 degrees. No? So we have 360 degrees is equal to 360 degrees. So check. Okay. Another example here. The observed interior angle of the triangle are A is equal to 35 degrees, 14 minutes, 37 seconds. B is equal to 96 degrees, 30 minutes, 9 seconds. And C is equal to 48 degrees, 15 minutes, 5 seconds. And determine the discrepancy for the given observation and the most probable value of each angle. Okay, so we are required to determine the discrepancy for the given observation and the most probable value of each angle. Okay, so A, B, C, this is the vertices of the triangle. We have A, 35 degree, 40 minutes, 7 seconds. B is 48 degree, 96 degree, 30 minutes, 9 seconds. C, we have 48 degrees, 15 minutes, 5 seconds. N is equal to 3. This is the number of observed angle. So to determine the is this. Sama ito, nawala. Nawala mo?
Nawala ang share screen, sir.
Nawala ang share screen. Bigat ka na, ganyan na eh. Sama ito. Okay, tama na. Okay. Okay, so let me share my screen. Okay, kita mo? Kita mo?
Yes, sir. Kita rin.
Yes, sir.
Okay. So determining the correction to be applied now. Sums of 1 is equal to A plus B plus C. That is equivalent to this is the sum of the observed interangles of triangle ABC. No? Get the sum of A plus B plus C. We have 79 degrees, 59 minutes, 51 seconds. So sums of 2 to determine the sum of the interior angle. No? We have from the formula. No? We have the formula, standard formula here. We have n minus 2 times 180 degrees. Okay. That is equal to 3 minus 2 times 180 degrees. That is equivalent to 180 degrees. Okay na? Discrepancy here is equal to plus or minus sum sub 2 minus sum sub 1. Okay. Plus or minus 180 degrees minus 179 degrees, 59 minutes, 59 minutes, 51 seconds. So the discrepancy here is positive 9 seconds. Okay. This is the discrepancy in the observation. Okay. Correction is equal to discrepancy over n, that is equal to plus 9 seconds divided by 3. Okay. Correction is equal to plus 0.3 seconds. Correction to be added to each observed angle. To be added because the sum of the observed interangles of the triangle ABC is less than 180. Okay, that's why we need to add. We need to add plus 3 seconds for each for each observed angle rather, or to each observed angle. We need to add the correction to each observed angle. So to determine the most probable value, we have A prime is equal to A plus the correction. So that is equivalent to 35 degree, 14 minutes, 40 seconds. B prime is equal to B plus the correction. That is equivalent to 96 degrees, 30 minutes, 12 seconds. C prime is equal to C plus the correction. That is equivalent to 48 degree, 15 minutes, 8 seconds. Okay, solution check. A prime plus B prime plus C prime is equal to sum sub 2. So 180 degrees is equal to 180 degrees. So check. Okay. Another example here, measurement of three horizontal angles. See accompanying figure about a point P or angle APB. Okay, APB here. So alpha sub 1, no? Equivalent to also alpha sub 1. That is equal to 12 degree, 31 minutes, 50 seconds. Then we have angle BPC, or that is alpha sub 2, equivalent to 37 degree, 29 minutes, 20 seconds. And CPD is equal to alpha sub 3, that is equal to 47 degree, 36 minutes, 30 seconds. Okay. The measurement of the single angle APB is equal to 97 degree, 37 minutes, 0 second. Determine the most probable value of the angle. Okay, so this is APD. AAPD here is equal to alpha sub 4. Single angle. Okay. Let's try to check if alpha sub 1 plus alpha sub 2 plus alpha sub 3 is equal to alpha sub 4. Okay. So solution here, we have the value of alpha sub 1, which is equal to APB, alpha sub 2 equal to BPC, alpha sub 3 is angle CPD, and alpha sub 4 is equal to angle APD. So the number of observed angle is 4 here. Okay. So determining the correction to be applied. No? Sum sub 1 is alpha sub 1 plus alpha sub 2 plus alpha sub 3. This is equivalent to 97 degrees, 37 minutes, 40 seconds. So sum sub 1 is the sum of the angles observed about point A. So we have the discrepancy here. No? Discrepancy is plus or minus alpha sub 4 minus sum sub 1. If you notice that sum sub 1 is greater than alpha sub 4. Okay, so we need to use a negative value so that we can subtract. Okay, we can subtract negative 10. We can subtract negative 10 inches. Oh, no, not inches, but seconds. 10 seconds to alpha sub 1, alpha sub 2, and alpha sub 3. So we have this one. Correction is equal to negative 10. Discrepancy divided by n. We have 10 seconds. Okay. Not only the alpha sub 1, alpha sub 2, and alpha sub 3, also the alpha sub 4 will be corrected also. Okay, it will be corrected. Okay. So we have here alpha sub 1 is equal to alpha sub 1 prime is equal to alpha sub 1 plus or minus a correction that is equal to 12 degree 31 minutes 40 seconds. Okay. Alpha sub 2 prime is equal to 37 degree. I mean alpha sub 2 prime is equal to alpha sub 2 plus or minus the correction that is equivalent to 37 degree 29 minutes 10 seconds. This is the most probable value of angle BPC. So the most probable value of angle CPD is alpha sub 3 prime is equal to alpha sub 3 minus the correction that is equivalent to 47 degree 36 minutes 20 seconds. So alpha sub 4 is equal to alpha sub 4 minus the correction or plus the correction. Why plus the correction? Because as you will notice that the value of alpha sub 4 is less than the sum sub 1. So you have to add it here para mabalance sila. Okay? So alpha sub 4 prime is equal to 97 degree 37 minutes 10 seconds. Okay. So that is equivalent to, they are already balanced now. 97 degree 37 minutes 10 seconds is equal to 97 degree 37 minutes 10 seconds. Okay. So we have here the concepts and principles about MPB, the most probable value. Okay. So do you have any question? Any question? Okay.
Ang discard kay dili kita nilio.
Ha?
Ang discard sa to dili kita nilio.
Kinsa man?
Sila mag-alert. Kaya under mo ta sa extension. Ilang isa na to balik.
Si, sila mo kuan.
Ilang format niya sila mag-process. Kaya ka na sila ng office.
Sila mo process? Naman sila mo process.
Ito mo. Receive ka sa mga. Pero mo may October na siya. Naghimo na kayo ba? Ito nga. Oh. Uy. Bago man igaling do. Ako pa biya before.
Dili kay ang nagsulti man ng office sa president nga kay mo ang test card. Oo.
Hindi na kayo kasi mga site in department. On pa na, kung hindi ka na sa ako extension, sa
Partner.
extension office na siya bitan. Kasi lang mo, hindi dali, sa process, assume sa process.
Kita na lang process, ilahan na lang ko ang documents.
Dito mo send sila to.
Ha?
Send sila to.
Sige, after my class, ako mo adto. Ikaw na lang paperma kay Sir Galindo. Ha? Ha? Okay? Any question, class? Am I audible?
Yes, sir. You are
Yes, sir.
audible.
Yes, sir.
Huh? Understand? So the process is very easy, no? In here. Huh? Okay? All you have to do is to determine the mean or the average. No? That is the concept under MPB, no? Under the theory of probability. Huh? Okay, so the next topic to be discussed here, this is also a corrections, no? We applied. Okay. So we have here the residual, no? Okay. The residual is also known as deviation. Deviation. Okay. So the value here is being deviated, no? So we have the corrections here to be applied. Huh? Okay. The deviation here is defined as this is the difference between any measured value of a quantity and its probable, most probable value. Okay. The difference between the measured value of a quantity and its MPB. So since you have already the knowledge of how to determine the value of our MPB, then this formula is very easy to you. Huh? So V, or shall we say mu, no? Mu or B, no? Is equal to x minus bar x. Take note, bar x here is the most probable value. Okay? V or mu is the residual in any measurement. X is a measurement made of a particular quantity. Bar X is the most probable value of the quantity. Okay. So we have also the probable error. Okay. The probable error here, okay, is a quantity which, when added to and subtracted from the most probable value, defines a range within which there is a 50% chance that the true value of the measured value or measured quantity lies inside or outside the limits of the set. No? Okay. So what is the meaning of this? No? Okay. I'm going to discuss this through this figure. No? Okay. On the second literature here, it says that this is the error that will be found in the middle place. No? This is the middle place here. As shown in the figure, this is the middle place. No? Okay, between 99.25 to 100.75. Okay, or 95% between 98.5 to 101.5. No, this is the probable error. Okay, so this error can be found in the middle place of arrangement that will possible be found in the middle place. Ay, problema, no? That will possible be found in the middle place of the arrangement such that one half of the errors are greater than it and the other half are less than it. Okay. So this is the probable error of a single measurement. It is equivalent to, more or less, that is equal to 0.6745 square root of summation of b squared over n minus 1. What is b again, class? What is B here? Huh? What is B?
Residual, sir.
Residual, no? Residual. Okay. So the point, if you can see in the figure, that is equivalent to 68%, no? But in here, this is 67.45%. No? More or less, medyo the most accurate formula here is this one, no? 0.6745. Square root of summation of b squared over n minus 1. Where e here is the probable error. This is the probable error of a single measurement. No? Okay, square root of summation of b squared over n minus 1. This is the sum of the squares of the residual. N is equal to the number of observation. Okay, this is for the single measurement. For the repeated measurement, you can use this normal distribution. Okay. The probable error of the mean is equal to, okay, 0.6745 square root of summation of b squared over n times n minus 1. Or summation, the probable error of the mean is equal to e over the square root of n. Okay. So that is probable error of the mean and probable error of the single measurement. So we have two formulas already. We have also the standard error. The standard error is equal to the standard deviation over the square root of n. Or the standard deviation is equal to square root of the summation of b squared over n minus 1. Okay. So we have here the standard error and the standard deviation. Standard deviation again is equal to the square root of summation of b squared over n minus 1. If you notice standard deviation, what is this formula? This is equal to the sum of the squares of the residual. No? Is that correct? Is that correct, class? No?
Yes,
The
sir.
sum of the squares of the residual. Okay. We have also the relative error precision. Okay. The relative error precision here is the total amount of error in a given measurement. Okay, it should relate to the magnitude of the measured quantity in order to indicate the accuracy of the measurement. Okay, so the relative precision in terms of usually fraction man, 1 over something. 1 over something. Okay, that is uh, the measured quantity in order to indicate the accuracy. So we have the total amount of error in a given measurement. So we have the relative error precision. Okay. In surveying measurement, okay, the ratio of the error to be measured quantity, error of the measured quantity is used to define the degree of refinement of obtained. Okay. So the relative error is also called as relative precision. It is expressed by a fraction having the magnitude of the error in the denominator. So 1 over the magnitude of the error in the denominator. Numerator is 1 divided by the magnitude of the error in the denominator. That is the relative error or relative precision. Okay. Let's say, for example, example of relative error precision. If for a particular measurement, the probable error of the mean is 0.1 meter, and the most probable value of the measurement is 235.5 meter, so we have the MPB of the measurement, a single measurement. When you say MPB, we have a single measurement here, 235.5 meter. So the relative precision here, take note that the probable error of the mean is given as 0.1 meter. 0.1 meter. So therefore, the relative precision RRP will be expressed as 0.1 divided by 235.5 or 1 over 2,335. Also written as 1 is to 2,335. Okay. For M and every 2,335 of measurement, you have 1 meter of error. Huh? 1 meter of error. Okay. So, okay, we have the probable error divided by the MPB of the measurement. Another example here, the following values were determined in a series of tape measurements of a line: 1,000.58, 1,000.4, 1,000.38, 1,000.48, 1,000.4, and 1,000.46 meters. So determine the following most probable value of the measured length. Okay, MPB should be a single uh, value. No? Probable error of a single measurement and the probable error of the mean. There's C, final expression of the most probable length. D is relative precision of the measurement. So letter A, we are going to determine the MPB. Okay, MPB is just equal to the summation of x divided by n. N is equal to the number of observation here, 6. No? Okay, summation of x is equal to summation of x sub 1 plus summation up to x sub 6. Okay, summation of x is equal to 602.7 meters. Okay, MPB or bar x is equal to summation of x divided by n. No? So 6,002.7 divided by 6. So our MPB is equal to 1,000.45 meter. This is the most probable value of the measured quantity. Letter B, we are required to determine the probable error of a single measurement and probable error of the mean. Huh? Okay, we have the residual here. Okay, the residual is ang x sub 1 is the measured quantity, no? Measured quantity for number 1, x sub 2, number 2, x sub 3 is number 3, number 4, number 5, and number 6. No? So we have that. So v sub 1 here, no, is equal to positive 0.13. No? So x sub 1 is the first measurement. No? It is given in the problem, 1,000.58. Okay, 1,000.58 minus the residual, MPB, sorry, MPB. Okay, so that is equal to positive 0.13. B sub 2 is negative 0.05. B sub 3 is negative 0.07. B sub 4 is positive 0.03. B sub 5 is negative 0.05. B sub 6 is positive 0.01. Okay. If you notice, summation of B here is equal to 0. Okay. So B sub 1 squared is 0.0169. B sub 2 squared is 0.0025. B sub 3 squared is 0.0049. B sub 4 squared is 0.009. 0.0009. B sub 5 squared is 0.0025. B sub 6 squared is 0.001. 0.0001. Summation of V squared is equal to 0.0278. So we have the measured length in x, okay, x sub 1 up to x sub 6, residual B, V sub 1 up to V sub 6, square of the residual b sub 1 squared up to b sub 6 squared. No? So get the summation of x here, 6002.7. Summation of b is 0. Summation of b squared is 0.00278. So this is the probable error of a single measurement using this formula. So we have plus or minus 0.6745 times square root of summation of b squared is 0.00278 divided by n minus 1, 6 minus 1. So E is positive, plus or minus 0.05 meter. This is the probable error of a single measurement. Probable error of the mean here, we have this formula, no? We have this formula. A sub m is equal to plus or minus 0.6745 times square root of summation of b squared over n times n minus 1. Or E sub m is equal to E over n man na siya. E over n, no? You can use the formula E over n for E sub m. No? Or using this formula, we have plus or minus 0.6745 times square root of 0.0278 divided by 6 times 6 minus 1. E sub m is plus minus 0.02 and this is the probable error of a mean. C, therefore, okay, the C here requires us to, okay, final expression of the most probable length. Final expression. We have to describe, no, about the most probable length. Therefore, the length of the measured line will be expressed as 1000.45. This is the MPB, no? Okay, plus or minus the probable error of the mean. No? Instead of using, kung single lang, mas dako pa siya, no? Compared to the mean. Expected na siya nga ang probable error of the mean is less than with the probable error of a single measurement. Okay? Single measurement considering that we consider the uh, kanang bar x na to determine the p. Okay? So we have to use the length of the measured line may be expressed as 1000.45 plus or minus 0.02 meters. This means that 50% chance that the true distance measured probably fails between 100.43, 1000.43, 1000.45 minus 0.02. It becomes 50% no, probability that the that the distance, no, the true distance may fail between 1000.43 meters and 1000.47 meters. And its most probable value is 1000.45 meters. There is also ever a 50% chance that the true distance lies outside this range. No? Okay, that is the expression that we can give for the true distance measured. No? So, the final expression for the most probable length. No? Letter C, to determine the relative precision. No? Relative precision is given by the error since with respect to the probable error of the single on or the mean for the mean. Uh, so since for the single measurement we have a greater value compared to the mean, so we can use in computing for the relative precision we can use the probable error of a single measurement. So therefore we have E over MPB is equal to 0.05 divided by 1000.45. So we have 1 over 20,000. This is the relative precision of a single measurement. It means that for every 20,000 meters, we have an error of 1 meter. That is how we interpret the relative precision of a single measurement. Okay? I stand corrected, no? This is for the single measurement, no? For the mean, we can use the mean, no? The error on the probable error on the mean. I stand corrected. No? I stand corrected. For the single, 0.05 divided by 1,000.45. For the mean is 0.02 divided by 1,000.45. So it is our advantage, no? To use Disadvantage to use the relative precision for the uh, mean, no? For the mean, because for every 50,000 meters, no, there is a corresponding error of 1 meter. 50,000 is to 1, no? Or 1 is to 50,000. And then for the single measurement is 1 is to 20,000. We have also the weighted observation. No? So many surveying measurements are made under different circumstances and conditions. Therefore, we have a different degrees of reliability, and often encountered is how to combine this measurement and determine the most probable values. No? Considering that we have a different circumstances, or we have a different weight or different yes, circumstances, no? So depending on the what is the degree of the circumstances or reliability, then we'll be able to come up with the most probable values among the measurement. If we are going to combine it, we'll be able to determine the MPV, the most probable values. Okay. In this situation, for every situation here, we're going to estimate the degree of reliability. The degree of reliability is also known as the weight, degree of weight here, for each of the measurement before they are going to combine and the most probable areas are determined. Okay, in here, what is the meaning of this? We are going to consider the degree of weight in the computation of each measurement. When we combine each measurement, we have to consider the degree of reliability or the degree of weight. Our endpoint here is to determine the most probable value, a single value here. And the assignment of relative weight to different measurement is usually based upon the judgment of the surveyor. Okay, depending on the what is the judgment or what is within the kanang imuhang kung sa na sa utak sa surveyor pag analyze niya, then come up with the judgment of that. Okay, the number of measurements taken for a particular quantity, and by assuming the weights are inversely proportional to the square of the probable errors. So we have the definition of weight here. So that is, we have the inversely proportional to the square root, the square of the probable errors. So the weight here is inversely proportional to the square of the corresponding probable errors. So W sub 1, weight 1 is K over E sub E squared. K is to be solved. Okay. Okay. W sub 1 is equal to K over E sub 1 squared. W sub 2 is equal to K over E2 squared. W sub 3 is equal to K divided by E sub 3 squared. Okay, so W1 is equal to E sub 1 squared is equal to W sub 2 is E sub 2 squared is equal to W sub 3 E sub 3 squared. Or W1 divided by W sub 2 is equal to W E sub 2 squared over E sub 1 squared. Okay, W sub 1 divided by W sub 3 is equal to E sub 3 squared over E sub 1 squared. Okay. In here, the weight are also proportional to the number of observation. Okay, number of observation. Take note of this. No? Okay. Depending on the number of observations here. Errors are directly proportional to the square root of the distances. Square root of the distances. Okay. Directly proportional. No, not inversely, directly proportional. That is equal to a certain value, square root of the distances. This is how we are going to determine the MPB, no? Using the weighted observation. Let's say, for example, for measurements of distance were recorded as 284.18, 284.19, 284.22, and 284.28 meters. And the given weight of 1, 3, 2, and 4, respectively. Determine the weighted mean. Okay. 284.18 meters, so then assigned weight is 1. 284.19 meters, assigned weight is 3. 284.22 meters, assigned weight is 2. 284.2 meters, assigned weight is 4. Okay. P is equal to measured length times W. We have 284.18. We have 285.57. 568.44. And we have 1,136.8. Summation of W is equal to 10. Summation of P is equal to 2,841.19. So the weighted mean here is, okay, summation of P divided by summation of W. We have 284.2 meters. So this is the most probable distance measured based on this formula or weighted mean. Another example here, it is desired to determine the most probable value of an angle which has been measured at different times by different observers with equal care. Okay, the values observed were as follows. In two measurements, we have 74 degree, 39 minutes, 45 seconds. Okay. In four measurements, 74 degree, 39 minutes, 27 seconds. And in six measurements, we have 74 degree, 39 minutes, 34 seconds. So we have here the values observed or observed values, and we are required to determine the most probable value. Okay. So we tabulate it now. Measured values is we have three measured values, number of observations here. Okay. And the number of observations refers to in two measurement, meaning two. Number of observations is 2. Four measurements, number of observations is 4. 6 measurements is number of observations is 6. Okay, the number of observations, the summation of that is 12. The product of the two quantities, 74.39 minutes 45 seconds is times 2 is 149 degrees 19 minutes 30 seconds. 74 degrees 39 minutes 27 seconds times 4 is 298 degrees 37 minutes 48 seconds. And we have the 74 degrees 39 minutes 35 seconds times 6. That is 447 degrees 57 minutes 30 seconds. summation of the product of the two quantities, we have 895 degrees, 54 minutes, 48 seconds. So the weighted mean here is equal to summation of the product, 895 degrees, 54 minutes, 48 seconds, divided by summation of W, divided by 12, that is 74 degrees, 39 minutes, 34 seconds. This is the most probable value of the angle measured. Okay. So another example here is the lines of levels to the lines of levels establish the elevation of the point are run over 4 different routes or ropes. The observed elevations of the point with probable errors are given below. Determine the most probable value of the elevation of the point. Okay, we are required to determine the MPV of the elevation of the point. Okay, take note, we have 4 different ropes. Line 1, 2, 3, and 4. Observed elevation, we are given with the observed elevation 219.832 for line 1, 219.93 meters for line 2, 219.701 meters for line 3, 220.021 meters for line 4. The probable error here is positive 0.006 meters for line 1, positive plus or minus 0.0012 meters for line 2, plus or minus 0.018 meters for line 3, plus or minus 0.024 meters for line 4. The square of the probable error is we have 0.000036 for line 1, 0.000144 for line 2, 0.000324 for line 3, 0.000576 for line 4. The weighted here is 1 over E squared. 1 divided by this one, E squared is we have this value. We have this. And then the sum here for relative weight here is, okay, what is the relative weight? Okay, since ang pinakagamay diri sa W is 1,736, that is our judgment, no? Mo nang gamiton nato as a divisor diri sa to determine the relative weight, no? As a divisor, pinakagamay. So ibig sabihin, 27,778 divided by 1,736 is equal to 16. 6,944 divided by 1,736 is 4. 3,086 divided by 1,736 is 1.78. 1,736 divided by 1,736 is 1.0. Okay, the sum of relative weight is 22.78. Okay, we have P, the product here is elevation times R sub W. We have this value, no, for line 1, 3,517.312. For line 2, okay, line 2 is 219.93 times 4, no? We have 879.72. For line 3, we have 391.068. For line 4 is 220.021. The sum of that is 5,008.121. Okay, so R sub W1 is equal to, this is the computation, no, for to determine the R sub W. Butang lang ako para di mo malibog. Okay, so the weighted mean here is summation of P divided by summation of W. We are given by 219.845 or 219.85 meters. Now, this is the most probable value of the elevation of the point. Okay, another example here. Okay. Another example is the length of a line was measured repeatedly on 3 different equations, and The most probable error of its mean values was computed with the following results. First set of measurement, 1,201.5 plus or minus 0.002 meters. Second set of measurement is 1,201.45 plus or minus 0.04 meters. Third set of measurement is 1,201.62 plus or minus 0.05 meters. Determine the weighted mean of the three sets of measurements. Now, solution. Okay, we have line A here, A, B, C. No? Observed elevation is 1,205 and the probable error is 0.04. No? The second set of measurement, line B, is 1,201.45. Then probable error is plus or minus 0.04. And the third set of measurement is 1,201.62. The probable error is plus or minus 0.05 meters. Then we will get the value of E squared here. Okay, 0.0004 for line A, 0.0018 is for line B, 0.0025 for line C. Okay, W here is 1 over E squared. So we have 2,500 for line A, 625 for line B, 400 for line C. If you notice, 400 ang pinakagamay din na for W. So in the computation for relative weight as shown in there, we have 2,500 divided by 400 is 6.25. 625 divided by 400 is 1.56. 400 divided by 400 is 1.00. The sum is 8.81. Okay, the product is 7,509.38. We multiply P times, E elevation times R sub W. For line B, we have 1,874.26. For line C is 1,201.62. Summation of that is 10,585.26. Okay, so the weighted mean of the three sets of measurement is 1,000, 10,585.26 divided by 8.81. We have 1,201.51 meters. This is the most probable value of the line measure. Actually. So we will continue with submission of errors by next meeting. When is our next meeting?
Wednesday, sir.
Wednesday. I'm preparing for my next class. Okay. Section, I think this is section 2 to 6. Okay, for our next. Anyway, gamay naman lang siya, summation of errors. By Wednesday, tapuso na to, then we will, gamay naman lang, siguro mga 10 to 15 minutes will do for this. Okay? And we will start with chapter 2 also, discussion of chapter 2 by next meeting. Okay? Okay? By the way, do you have any question?
Not so far, sir.
Okay, hearing none, the computation is very easy. The computation is very easy. Okay, Mayor, kindly check the attendance. As of now, we are 26. Kailan mo tanan? Mayor? Wala si Mayor. Si Vice Mayor.
Nahutdan og load ang mayor, sir.
Pinahot na lang. Luoy man, no? Isa man ang Vice Mayor dere.
Ako, sir. 28 minutes na lang, sir.
28 mo. So, 25. So, 28 na itulong absent, no? So, you have to take note, those absent. Okay, kaya pangayuan na mo ba attendance, Okay?
Yes, sir.
Okay. So the class is dismissed. May God bless us all. See you next meeting. Bye-bye.
Thank you, sir. God bless you, sir.
Sir.
Bye.
Thank you. Bye-bye.
Thank you, sir.